Assalamu alaikum. My name is Guitoum Djamel from Research Unit on Optics and Photonics. In this work, silver nanoparticles were deposited on porous TiO2 films by photodeposition technique. Porous TiO2 films were prepared by adding polyethylene glycol to the starting solution. In this work, we studied the effect of UV irradiation time used for the photodeposition of silver on structural, optical, and photoelectrochemical properties of porous TiO2 films decorated with silver nanoparticles. Figure 1 presents XRD spectra of the prepared samples on ETU substrate. We know the presence of small peaks attributed to TiO2 anatase structure. No diffraction peak of silver was detected due to the dominance of ETO peaks and the low amount of silver. To confirm the presence of the silver, XRD patterns of films deposited on glass substrates are presented in Figure 2. Beside the peak of anatase, we know the presence of a peak assigned to silver, and the intensity of this peak increased with UV irradiation time increased due to the growth of silver amount. Figure 3 presents SEM micrographs of pure TiO2 films prepared with and without PEG, and the film prepared with 25 minutes of UV irradiation time. The surface morphology of the film with PEG is rough and porous compared to the one without PEG. The white spots in Figure C presents the silver nanoparticles, which seem to be homogeneously distributed on the porous TiO2 film surface. Figure 4 presents UV visible absorption spectra of the prepared films. Compared with porous TiO2 film, compared with pure porous TiO2 films, all the silver-loaded films present an enhancement of the absorption in the entire visible region, which is ascribed to the localized surface plasmon resonance LSPR of silver nanoparticles. Figure 5 presents cyclic voltammograms of TiO2 films prepared with and without PEG. Under simulated solar light, the generated photocurrent from porous TiO2 film with PEG is greater than that generated from TiO2 film without PEG, which is due to its higher specific surface area. Figure 6 presents cyclic voltammograms of porous TiO2 film and silver-loaded porous films. Under simulated solar light, the photogenerated current from all silver-loaded films is greater than that from pure porous TiO2 film. Moreover, the current density increases with UV irradiation time increase from 10 to 15 minutes and decreases for the samples prepared with 25 minutes of UV irradiation time. These results are in well agreement with those obtained from UV visible absorption spectra. Thank you.